I wanted to do some more examples from that same test. Um, I'm actually able to do problems number 5 and number 6 from the first test also. So I think that's 25, 35, 40 points from the first test you could do just using a calculator. Well, let me paste this in. This isn't the only way we're gonna learn how to do these, obviously. Now, the first thing I usually look for in these, where you gotta create your own graph, is I look for any points that are given to me. For example, in part 5, I see f of 1 equals 3. So I'll put a dot at the point 1 comma 3. So I've got that one taken care of. Now everything else is a left and right, well, most everything else is a left and right limit. The limit as x goes to negative 3 from the left is infinity. So that means x equals negative 3 is automatically an asymptote. I'm not sure why that little dash doesn't go where I want it to. Try again, one last time. Okay, so if it goes to infinity, I can have a piece of graph on the left side of negative 3 going straight up. Put an arrow at the end of it to indicate that it's going to infinity. Now let me manage the other side. The limit as x goes to negative 3 from the right is negative infinity. So I can just do a similar thing with the arrow pointing downward. Okay. Oh yeah, let me put check marks. It's a good idea to put check marks on whatever you handled. Now let me go. The limit as x goes to 1 from the left is negative 2. So I need, there we go. See, there it goes. There it is at 1, negative 2. And then the limit as x goes to 1 from the right is 3. I've already got a point at 3. So let me continue some graph attached to that point. There we go. Now I'll hold off for just a second here. You should know that at the point 1, negative 2, you have to have a hole. Because if you don't, the function will not pass the vertical line test because it already has a point at 1, 3. Now for the last piece, x goes to infinity, the function approaches negative 1. So I'll draw a horizontal asymptote at y equals negative 1. Let me erase the graph that I had and make a graph that contours to that horizontal asymptote. So there you go. There's a way, you can draw the graph based on just the things you've seen so far. Now it's actually possible. We're going to do more with this. This involves derivatives, but we can at least do the limit right now. So let me pull that one in. Paste it in. And then I'm just going to throw it into the calculator. I'm going to try to dispatch this as quickly as possible. This is the limit as x goes to 27 of the cubed root of x minus 3 divided by x minus 27. Now, instead of the cubed root, I'm going to write x to the 1/3. And I'll do my minus 3. And I just realized I forgot my parentheses around the numerator. So let me put one after and before the x to the 1/3 minus 3. To put it before, make sure you hit the insert button. That's above delete. Parenthesis. Good. Now let me put my x squared, or x minus 27 in the denominator. Of course, it needs parentheses too. What I'm going to try to do is really knock this out quickly. I am going to go, since we're going to 27, I'm just going to go right to the table. I'm going to set my initial point at 27. And then my delta table, my increments, I'll do 0.000, 4 zeros and a 1. And let's check the table values. Well, look at that, 0.03704. all over the place. You notice on the left it says 27, but technically it's 26 point something and 27 point something. So I feel pretty confident. To 3 decimal places, I've got this answer done now. 0.037. Once again, this is the screen I'll use for my evidence. Stretch it out. This thing kind of, it's still taking me a while to get used to some of the things, some of the rubber looking things that happen on this screen. Let me circle the important numbers. And we're finished. Answer is 0.037.